So taking a look at example number 2, it says that a shot put throw can be modeled using the equation y equals negative 241 10,000ths times x squared plus x plus 5 and 5/10ths, where x is the distance traveled in feet and y is the height also in feet. So again, my x and y axis are both distances. One is horizontal, one is vertical. Now it's asking me how long was the throw, when does the shot put reach the maximum height, what is the maximum height that the shot put reaches, and what is the height of the shot put when it's 15.5 feet away from the thrower. So I am going to take my equation and I am going to graph it into Desmos. Clear that out. Now I'm going to graph my new equation. So I've got negative 0.0241. Again, that was the 241 10,000ths, if we're being precise, plus x plus 5.5. And if I look, I can see, hey, I threw it at about 5.5 feet above the head. And now I've got a vertex, I've got an x-intercept of where it stopped or where it landed. I should be able to figure out a good amount of information. So if I go back over to my question, it says how long was the throw? So what I care about is, hey, I started at 0, and when I threw the ball, it landed at 46.411. So the throw was 46.411 feet. It then asks me, when does the shot put reach its maximum height? And it reaches its maximum height here at this point. The x value is 20.747. That maximum height is 15.873. And since it's asking, hey, when does it reach the maximum height, it means it's asking for the x value. The x value is 20.747. And that's a horizontal distance of 20.747 feet away. Now, if you were to take that 20.747 and multiply it by 2, you would wind up getting your total distance. Pretty crazy. Now, what is the maximum height that we reach? That's going to be the y value of my vertex. And that y value is 15.873 feet. And then it asks for the height of the shot put when we are 15.5 feet away from the thrower. And so what I'm going to do is I'm going to take my equation, I'm going to go to settings, I'm going to click on the table, and I'm going to plug in 15.5 feet away. And when I plug in 15.5, I can see that the output that I'm given is 15.21. In the table it says 15.209975, but since it wants me to round to the nearest hundredth, I'm going to use 15.21. And now we have how far away it is. So again, we just need to know, when I plug in the graph, what is it actually representing? Where do my starting and stopping points look like? What is my x-axis? And what is my y-axis? Let's do another one. Amy tosses a ball in the air in such a way that the path of the ball is modeled by the equation negative x squared plus 6x. In the equation, y represents the height of the ball, and x is the time in seconds. So we're going to go ahead and graph this in Desmos. So we've got y equals negative x squared there we are, plus 6x. And now I've got my 3 key points, and we're going to go back and see what questions we can answer. At what time is the ball at its highest point? Time is my x values, and we can see that I have a maximum of 3, 9, or a vertex of 3, 9 rather. The x value, or the time component, is 3, and the y value, or the height, is 9. So it reaches its maximum at the 3-second mark. The maximum height of the ball is going to be the y component of my vertex, which is going to be 9 feet above the ground. And then it wants us to figure out where does the ball reach the ground. And it looks like my ball reaches the ground at the 6-second mark. Again, if we want to take a look at our throw, I mean, you know, when you throw something, it goes up, it goes down. And so when we take a look at that graph, I've got, it starts at 0, 0, travels up and reaches a height of 9 at the 3-second mark, and then it hits the ground at 6. Again, we can get this algebraically, but I really just need you guys to be able to read the graph. So feel free to graph it in Desmos and get your answers. Last one for this video. Example 4. The daily cost per car manufactured at a certain automotive plant decreases as the number of cars increase, and then increases again due to overtime production costs. The cost C per car is given by the function C of n is equal to 0.3 n squared minus 90n plus 12,450, where n represents the number of cars produced. Which of the following is the lowest per car cost? And it's a multiple choice question. So I've got 4 possibilities I need to figure out. Is my cost going to be my x value or my y value? Now this function is laid out as a C of n. Now n is the input because that's what's in my equation. So n is the input, and n represents the number of cars, which means that C is my cost. Again, C is the cost, or the y value. So my lowest cost is going to be the lowest y value that I get when I plug this into Desmos. So if I go over to Desmos and I clear out my last equation and I type in y equals 0.3 x squared minus 90x plus 12,000, 450 I can see that I've got a pretty big parabola that's really, really, really high up there. It doesn't have any roots, it doesn't have any x-intercepts, there's no real starting or stopping point. I could, of course, change the window, but, I mean, a parabola is a parabola. So I found it, I'm going to click on it, I'm going to click on the vertex, and it looks like with an input of 150, my lowest output, or my lowest cost, is 5,700. So if I'm making 150 cars, the cost per car is 5,700, and that would be the minimum or the lowest cost. Again, it has 12,450 is a y-intercept. So that's the cost before I've produced anything, or when I'm producing just a car. But like it says, the cost per car at a certain automotive plant decreases as the number of cars increases, but then it increases again because of overtime production costs. So the more people are working and the more cars that get made, eventually the profits taper off. And that's what we're able to see in our graph. The cost goes down, 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 and then it slowly starts to curve back up because of the overtime.